we've learned that there is a globally predictable gradient in seasonality caused by the tilt of the Earth on its axis in relation to its path around the Sun. As you move toward the tropics from the poles, abiotic conditions become relatively constant, and on average, conditions are warmer and wetter. These extremely broad global patterns largely explain the latitudinal distribution of the boreal, temperate, and tropical forest biomes. Remember in the introduction, I mentioned some lesser-known forest types, including the tropical deciduous forest. These seasonal forests are characterized by a long dry season and tend to occur at intermediate latitudes, between about 10 and 25 degrees. To understand the distribution of this forest, we need to discuss global rainfall seasonality. This graph shows where the sun is directly overhead for each month of the year. Where the sun is directly overhead, it heats the earth below, clouds are formed, and precipitation follows. Now look at the latitudes where we find tropical deciduous forests in the northern hemisphere. From March to September, the sun passes over these latitudes, bringing precipitation. Then, from September through March, these forests enter a dry season, while the sun is over the southern hemisphere. The opposite is true for the tropical deciduous forests in the southern hemisphere. Another big factor that influences the distribution of forest biomes is wind. The spin of the Earth from west to east on its axis creates a Coriolis Force, which deflects free-moving masses, such as air and water. The Earth's surface moves much faster at the equator than at the poles because their circumference is much larger. So there's a deflection of air masses to the right in the northern hemisphere and to the left in the southern hemisphere. These winds are known as the trade winds because they powered merchant ships from Europe to the New World. At higher latitudes, air masses moving poleward are deflected in the same direction, right in the northern hemisphere and left in the southern, producing the westerlies. The impact of the trade winds on climate, and thus vegetation, can be seen in this precipitation map for South America. Notice that the Amazon basin has higher rainfall in the west than in the east. That's because the trade winds push moisture-laden air from the east, resulting in more rainfall in the western Amazon. The Coriolis Force is also evident in major ocean currents. Surface water pushed by wind is deflected to the right in the northern hemisphere, setting up a clockwise rotation, and to the left in the southern hemisphere, resulting in a counterclockwise flow. Look at the Atlantic Ocean. Warm water from the tropics, represented by the red arrows, is pushed westward by the trade winds, but is deflected to the right in the northern hemisphere, forming a warm current known as the Gulf Stream that runs along the eastern United States. As the Gulf Stream reaches temperate latitudes, it cools and is pushed eastward by the westerly winds, continuing to be deflected to the right. The result is a cold current that flows back toward the equator off the west coast of Europe and North Africa. This circulation pattern is the same in all the world's oceans. It results in warmer waters off the east coasts of all the major continents and colder waters off the west coasts. Which side of the continents, then, have wetter vegetation types? Check out North America. There's forest in the east, fed by that moist air of the Gulf Stream, and desert and scrub in the west, kept dry by west winds off the cold California current. South America, too, forest and grassland in the east, but in the west, the Atacama Desert, the driest place on Earth, adjacent to the cold Humboldt Current off the continent's west coast. Australia is the same. Rainforests and temperate forests only occur in the east, and drier ecosystems are in the west. Lastly, I need to mention elevation. When an air mass hits some topography, like a mountain range, it's forced up and over it, pushed by the wind behind it. As this air rises, it cools at a fairly predictable rate of around 6 degrees Celsius for every 1,000 meters. This is called the adiabatic lapse rate. As you know, cooling air loses its water. So a couple of interesting phenomena come out of this. One is that the windward side of a mountain is usually rainier than the leeward side. The second is that the other side of the mountain is drier, a phenomenon known as the rain shadow effect. You can see the rain shadow effect very clearly in the precipitation map of South America. The Andes Mountains block moisture blowing in from the east on the trade winds. The eastern side of the Andes thus receives tons of rain, but dry forest and deserts occur on the western side. You should now have a well-rounded knowledge of the complex but predictable climate factors that shape global vegetation. Now, when you look at any biome anywhere on Earth, you should be able to explain why it occurs there in terms of global climate. Start with the biome you live in. Why is it found there?